The parabola, chapter 10, section 2. So a parabola is the collection of all points P in the plane that are the same distance D. Now, when we say in the plane, realize that we are looking at this in two dimensions. If you were to rotate a parabola around the axis of symmetry, then you would have a three-dimensional parabolic shape. So as I mentioned, your satellite receiver, your satellite dish, or the reflector for a flashlight, etc., if you take it into three dimensions. But we're going to deal with all this stuff in two dimensions. So it's a collection of all points P in the plane that are the same distance D from a fixed point F as they are from a fixed line D, capital D. The point F is called the focus of the parabola. The line capital D is the directrix. And as a result, a parabola is the set of points P for which the distance from F to P is equal to the distance from P to D. And you can kind of see, remember I talked about the reflection of it for a parabola, that if you had a little bulb at the focus, remember I said at a single point, and it were to go and from there and hit into the parabola, it would then get reflected such that all the reflections were parallel. And you can see when you're talking about the directrix that that's actually kind of the opposite of it. It's drawing the lines the other direction, but the angle between the line from the focus to the parabola and between the directrix and the parabola, they have the same angle from the parabola at that given point. But this is, so we have our parabola here, and it's basically just saying that the distance between 2 points, let me just do here. So the distance from the focus to any point on the parabola is the same as the distance from that point directly to the directrix. And that's where our formula for this is going to come from. So let's look at a little more information on and get the formula. So if we have a parabola where the vertex is at 0, 0. So this is really the simplest type of parabola you can have, where the vertex is located at the origin. The focus is at the point A0. So A is the distance between the vertex and the focus. And A, of course, being greater than 0 because a distance can't be negative. The equation of a parabola with vertex at 0, 0, focus at A0, and directrix x equal to negative A. Now, remember we said that A was the distance from the focus to the vertex. Well, the directrix is going to be the same distance away from the vertex on the other side. So that's why the directrix is located at x equal to negative A, where of course A is greater than 0, is y squared minus 4ax. So y squared is equal to 4ax. I don't know why I said minus. You'll give me a break on this one. Okay, so y squared is equal to 4ax. So that is a parabola that opens to the right, that has the vertex at the origin and the focus at A0. Anytime you have a parabola that opens to the right or the left, it's going to be in the form y squared equal to, if it opens to the right, it's equal to 4ax. If it opens to the left, it's equal to negative 4ax. If you have a parabola that opens up and down, then x and y are going to swap, and you'll have x squared is equal to 4ay if it opens up, or x squared is equal to negative 4ay if it opens down. So let's look at these and realize that all of these forms, like this sheet here showing you all the different formulas, not necessarily with the pictures on it, but all these different formulas depending on how it's set up, is on the formula sheet that you're allowed for exams. So let's look at the possibilities here. So these are all based on the vertex being at the origin. And the focus, if the vertex is on the origin, then the focus is on one of the axes, either the x-axis or the y-axis, dependent on whether this opens right, left, up, or down. So you see with the first one here that the vertex is at the origin, focus is then at a0, the directrix is at x equal to minus a, the equation yx squared and y squared equal to 4ax, and the description is that the axis of symmetry is the x-axis. If it opens right or left, then the axis of symmetry is the x-axis, assuming that the vertex is at the origin. We'll talk about if the vertex is not at the origin on the next slide. And it opens right. You can see the next one, the change is that the focus becomes at negative a, 0. The directrix is at x equal to a, so we just flipped it over the y-axis. Y squared is equal to negative 4ax, and the axis of symmetry is still the x-axis, but it opens to the left. If it opens up, we have the vertex again at the origin, the focus at 0a, because now y is what is changing because it's opening up or opening down. So this one is opening up. Y is equal to negative a. The equation is x squared is equal to 4ay, and the axis of symmetry is the y-axis. And it opens up. In the final case, vertex is at the origin, focus is at 0, negative a, directrix is y equal to a. The function, the equation is x squared is equal to negative 4ay. Axis of symmetry is the y-axis, and it opens down. Now, as I said, this table will be available on your formula sheet. You're allowed to use it, but I think you'll find with time, you'll just get used to how this works. Most of us are familiar with the equation y equals x squared. So x squared is equal to y. So we can see that the third one down, that's really of that form. X squared is equal to 4ay. Well, looking at that, we should be able to make a quick assumption about our basic formula, x squared equal to y, the parabola that we've used in the past. And that is that means 4 times a must be equal to 1 to make it x squared equal to 4ay. So a must be 1/4. So in our standard x squared equal to y parabola, the distance from the vertex to the focus is 1/4. So we can right here say that for that standard parabola, the focus is at 0, 1/4. The directrix is at y equal to negative 1/4. X squared is equal to y. The axis of symmetry is the y-axis, and it opens up. So we can see how with the simplest parabola that we've dealt with, how it fits into this. And you can see we've got the little pictures below to kind of give us a visual of what's happening. Now what we're going to do is we're going to move on to, well, what if the vertex is not at the origin? And it doesn't change things a lot. It just means that now we have to adjust for that shift in the vertex. So now the vertex, we're going to say the vertex is at the point hk. So h representing the x value, k representing the y value. A still has to be greater than 0. And now the axis of symmetry, instead of being on a coordinate axis, is parallel to the coordinate axis, right? Because if we have something that opens to the right or opens to the left, but now it's been shifted up and the vertex is at 5, 2, it's been shifted up by 2. Now the axis of symmetry isn't the x-axis, but it's parallel to the x-axis. So you can see here, if we have the vertex at hk, then, and we're dealing with one that opens to the right, then your x value is going to change to h plus a. So we remember that previously it was a0 for your focus. Now we have to account for the fact that it's been shifted by h, so it's h plus a, and the k and the what was 0, we have to add the k on, so now we have k. The directrix was negative a, x equal to negative a. Now it's x equal to h minus a. In the equation, we have to account for the shift, and that's done just by subtracting k from y and h from x, and that happens for all of these. So the equation was y squared is equal to 4ax. Now it's y minus k squared is equal to 4a times x minus h. And again, the axis of symmetry is still parallel to the x-axis, and it opens right. If we have one that opens left, same idea, but now the focus becomes h minus a, k. The directrix is x equal to h plus a. The equation becomes y minus k squared is equal to negative 4a times x minus h. If it opens up, the focus is at h k plus a. The directrix is at y equals k minus a. The equation is x minus h squared equal to 4a times y minus k. And then when it opens down, the focus is at h k minus a. Directrix is at y equal to k plus a. The equation is x minus h squared is equal to negative 4a times y minus k. So remember, for the focus and the directrix, you're going to use the same formulas that you did before, but now you have to add h and k to x and y respectively. And for the equation, it's the same formula as before, but now you subtract h and k from x and y respectively. And again, we have the pictures at the bottom to help us visualize this a little more. And you're able to have this table as part of your formulas for the exam. So let's put it to use, interpreting the equation of a parabola. So find the vertex, focus, directrix, 2 points on the lattice rectum, and I'll explain what that is in just as we go through this, and the direction that the following parabola opens. One of the first things you look for really is what direction does it open, because that tells you where to do everything else and how we have to treat it. So we're dealing with x plus 3 squared is equal to 4 times y minus 5. So when we're looking at this, the first thing I look at is I see that it's in the form x squared is equal to 4ay, which to me, that tells me that it's going to be opening up, because it's going to either open up or down because we have x squared. If it was opening right or left, we'd have y squared. So it's only going to open up or down. And I see a positive 4 or just positive on the right-hand side, period, because if it was positive 5, it would still be this. Since it's positive, that tells us it's either opening up or opening to the right. So the x squared tells us it's opening either up or down. The positive tells us it's opening either up or right, so it's got to be opening up. So that's going to put us into the form x minus h squared is equal to 4a times y minus k. And you can also just look at this equation and say, okay, well, I've got x plus or minus some value squared is equal to 4 times, so 4 times some value times y plus or minus some value. And that puts us into this form x minus h squared is equal to 4a times y minus k. So that tells us right there, since we're in that form, it does open up. The vertex can be found simply by using the x minus h and the y minus k. Well, I've got x plus 3, so it must be x minus negative 3. Be careful about that, your negatives and your positives on those. And I've got y minus 5, so k must be 5. So our vertex is at negative 3, 5. We also know with this form that whatever constant is in front of that y minus whatever, that's equal to 4a. So 4a is equal to 4, so a must be equal to 1 in this case. So we have the vertex, we have a, which means that I can now come up with my focus. And remember that the focus, if it's opening up, is equal to h comma k plus a. So h from our vertex, remember vertex is hk. So from our vertex, we get h is equal to -3, k is equal to 5, plus a is equal to 1. So our focus is at -3, 6. So you can think of this as we're really taking little equations and solving for variables along the way. So it's just a piece here, a piece there. The directrix is found by taking the y value, so h, and subtracting a. So y is equal to 5 minus 1, or 4. So y is equal to 4 is our directrix. Now that we have that, we're going to find the lattice rectum. And what is the lattice rectum? Okay, so here's time for explanation of what a lattice rectum is. It kind of sounds dirty to say it. But basically, the line that runs parallel to the directrix through the focus is the lattice rectum. So it's the line that runs through the focus that is parallel to the directrix or perpendicular to the axis of symmetry. 2 points on the lattice rectum that we look for are where it crosses the parabola. So where that lattice rectum crosses the parabola. And that can be found by plugging in the correct value from the vertex. If we're opening right or left, then we're going to plug in the x value of the vertex and find the two y values for our parabolic equation. If it opens up or down, we're going to plug in the y value of the vertex and find the two x values that solve our parabolic equation. So in this case, we are opening up, so we're going to plug in y from the focus, so that's 6. So when y is equal to 6, we have x plus 3. Remember from our original equation, x plus 3 squared. So x plus 3 squared is equal to 4 times, plug in 6 for y, 6 minus 5. So x plus 3 squared is equal to 4 because 6 minus 5 is 1. 4 times 1 is 4. Now we need to solve for x here. So we're going to take the square root of both sides. And remember, when you take the square root of both sides of an equation, you need to put that plus or minus in front of your square root. So x plus 3 is equal to plus or minus the square root of 4. Luckily, square root of 4 is really easy to find. That's 2. So we subtract 3 from both sides, and we get x is equal to -3 plus or minus 2. So now we're going to do that. -3 plus 2 is -1. -3 minus 2 is -5. And y is still equal to 6. That's what we had set it for. So the 2 points on the lattice rectum are at -5, 6 and -1, 6. Sorry, yeah. So now we have all these pieces, right? We have the vertex at -3, 5, the focus at -3, 6, the directrix at y equal to 4, 2 points on the lattice rectum, -5, 6 and -1, 6. And we know that the parabola opens up. So now that we have that, let's go on to going the opposite direction. With this, we started with the equation and we found all the pieces of information. Now what I want to do is I want to start with some information about it and use that to find the equation for the parabola. So find the equation of the parabola described. Find the 2 points that define the lattice rectum and graph the equation. So we have the focus at 2, 4 and the directrix is the line x equal to -4. So x equal to -4, that's a vertical line. The directrix, that means the axis of symmetry is going to be parallel to the x-axis. The focus is at 2, 4, h equal to 2, y equal to 4. All right, so let's take a look at this. So like I said, so vertex is at hk, and why this says, okay, there we go. So the focus is at 2, 4. So I misstated that. I'm not sure why. I guess I was thinking vertex because as I do this, I can see the next line. So the focus is at 2, 4. The directrix was at -4, x equal to -4. So halfway between 2 and -4 is -1. Remember, this is the same distance from the vertex to the focus as from the vertex to the directrix. So we're able to average 2 and -4 and get -1. So the vertex is at -1, 4. So h is equal to -1, k is equal to 4. Forgive me for my previous misstatement as I was thinking of the wrong word as I said it. So this is going to, since the directrix is a vertical line, the x-axis, well, I should say the axis of symmetry is going to be parallel to the x-axis. So this is obviously opening right or left. The directrix was to the left of the focus, or I should say the focus was to the right of the directrix. So therefore, or is further right than the vertex. Therefore, this must be opening right. Now, think about these things as you go through it. We know that the focus is going to be on one side of the vertex. We know the directrix is going to be on the other side. The focus, the side of the vertex that it's on, is the direction that it's opening. So if the focus is above the vertex, we're opening up. If the focus is below the vertex, we're opening down. If the focus is to the right of the vertex, we're opening right. If the focus is to the left of the vertex, we're opening left. So in this case, it's to the right of the vertex, so we're opening right. Then we can find A. A is the distance from the focus to the vertex. So 2 minus -1 gives us 3. So A is equal to 3. Now we can start plugging into the formula. We know this opens right. So therefore, the formula is going to be y minus k squared is equal to 4 times A times x minus h. We can plug in our vertex, which was -1, 4. So we have, and remember, it's y minus, so y minus 4 squared is equal to 4 times A was 3, so 4 times 3 times x minus -1. So y minus 4 squared is equal to 12 times x plus 1. Now we're trying to, if we want to get this into different formats, we want to be able to graph this equation. It says find the 2 points that define the lattice rectum, graph the equation. So we've got our equation for this. So now we need to find 2 points that define the lattice rectum and graph it. So we're going to solve for y here, since we know that what's going to be needed. We're going to need to plug in for x to get our points on the lattice rectum. So y minus 4 is equal to plus or minus the square root of 12x plus 12. So I did two things at once there. I took the square root of both sides and I distributed the 12 through the x plus 1. In the case, add 4 to both sides. So we have 4 plus or minus the square root of 12x plus 12. At x equal to 2, our focus is at 2. Y is equal to 4 plus or minus the square root of 12 times 2 plus 12. 12 times 2 is 24 plus 12 is 36. So 4 plus or minus the square root of 36. Square root of 36 is 6. So is equal to 4 plus or minus 6. So 2 points on the lattice rectum. 4 plus 6 is 10. 4 minus 6 is -2. So we have 2, -2 and 2, 10. which now we have all the things necessary to be able to graph this equation. So we use the 2 points on the lattice rectum to help us get the parabola shaped, right? We know where the vertex is. The 2 points on the lattice rectum really allow us to get the curve approximately right. So we don't have it too narrow, we don't have it too wide, and we don't have to just randomly plug in values to see what one of them is. We have a set way of doing it. Makes it nice and clean and a process to follow. So let's take this information and graph it. So I just transposed over the equation. Y minus 4 squared is equal to 12 times x plus 1. The fact that it opens right, so we can keep that in mind as we graph it. The focus is at 2, 4. The directrix is at x equal to -4. The vertex is at -1, 4. And the 2 points on the lattice rectum, LR, lattice rectum, 2, -2, and 2, 10. So now we're going to start plotting them. So the focus is at 2, 4. Directrix is at x equal to -4. The vertex, -1, 4. 2 points on the lattice rectum, 2, -2, and 2, 10. And then here you get to see what a graph looks like when I do it by hand using the computer. And we get our parabola that looks something like this. I ran out of space on the top. That's why it doesn't balance out going as far. But that's the basic idea. It looks better if you do it on paper because you're able to control your hand a little better than I'm able to control the mouse. But that allows us to go from pieces of information, the focus, the directrix, or whatever, certain pieces of information about a parabola, and come up with the equation and graph it. And we learned how to start with from the equation and find all the pieces of information about it.